Hello geometry students. Today's lesson is 2-1, Parallel and Perpendicular Lines. Please put your name, date, and period on your paper. The objectives for today. Students will be able to define parallel lines using the undefined terms point and line. You will also prove theorems about lines and angles. Students will use theorems to find the measure of angles formed by parallel lines and a transversal. Your vocabulary today. We have adjacent angles. Those are angles that are next to each other. So you can have an angle like this and an angle like that. They would be adjacent, next to each other. Supplementary angles are angles that add to 180. So a straight line that's made by two angles is called a supplementary, and they add up to 180 degrees. A linear pair is similar to supplementary angles and because they make a line. So that would be a linear pair, like angle 1, angle 2. Vertical angles are angles that are opposite of each other and they're equal. So like this angle and this angle, they make a V touching each other, and that's how I remember vertical. And this angle 1 and angle 2 are congruent, as well as this angle and this angle. They would be congruent to each other. 3 would be congruent to angle 4. Those are vertical angles. In this section, we have identifying the angle pairs. Which angle pairs include the named angles? So we have angle 4, which is right here. We want to know which angle pairs include that. So angle 2 is also a pair with angle 4. Angles 8 and angle 6. And then we want to look at 7, angle 7, which is here, and I'll use double marks to show that it is a pair with 5, and it pairs with 3 and 1, meaning that all of those angles are congruent because we have parallel lines cut by a transversal. So angles 7, oops, it is 7, angle 5, angle 3, and angle 1. So this purple line is the transversal. Transversal. And the black lines are the parallel lines, and we can see that by this marking here shows that they are parallel. Which gives us these angle pairs that we're talking about. In this little box here, we have some postulates and theorems. There are 4 special angle relationships formed when parallel lines are intersected by a transversal. So what are our key words here? We have parallel lines intersected by a transversal. And then there are these 4 special angle relationships that happen. All right, so the first one that we have is same side interior, and that would be the 1 and the 2. The relationship here is that angles 1 and 2 add up to 180. Then we have theorem 2-1, and the numbers are not so important as the names of it, because in a different textbook the numbers would be different. This is the alternate interior angles theorem. 1 and 2 are alternate interior, so they are on the inside of those parallel lines. Interior, they're on the inside, and they are equal to each other. So notice how the postulate, same side interior, they add to 180. Alternate interior are congruent to each other. The next theorem that we have, I'll change my highlighter color, is the corresponding angles theorem. And I like to think of corresponding kind of like a clock. They're in the same position of the clock. So the 1 is in the same position as the 2. And in that case, they are congruent, corresponding. And the last theorem that we have is the alternate exterior angles. That would be on the outside of the parallel lines, and those are congruent. And you can kind of see that they have the same angle to each other. Here we are going to explore angle relationships. If angle 4 is 118 degrees, what is the measure of each of the other angles? So let's start with the easy ones. We have angle 4 right here. Well, angle 2 and angle 8 and angle 6 are all angle pairs with angle 4. So then we can write that angle 2 is equal to 118 degrees. Angle 6 is equal to 118 degrees. And angle 8 is equal to 118 degrees. So now we want to figure out what angles 1, 3, 5, and 7 are. So what are angles 3, 5, 1, and 7 equal to? Well, we really only have to figure out one of those. And so I'm going to start with angle 3. Well, we'll start with angle 1. Angle 1 is a linear pair with angle 4, which means that angle 1 plus angle 4 has to equal 180 degrees. And I'll write that for you up here, just a linear pair adds to 180 degrees. So that means that angle 1 plus angle 4 equals 180. If we know that angle 4 is 118, then what plus 118 would give us 180? To figure that out, we just subtract 180 minus 118. 62 degrees. So that means that all of these angles have to equal 62 degrees. And that is the beautiful thing about parallel lines cut by a transversal. Next, we will prove a theorem. This is the heart and soul of geometry. We have parallel lines, and I'm going to label them L and M. And we want to prove that angle 1 and angle 2 are congruent. We can see that and we know corresponding angles, but we want to prove that corresponding angles are always congruent. And this proof will always work. So we start with lines L and M are parallel. And that is just given to us. Because in order for them to be corresponding angles, they have to be parallel lines cut by a transversal. So that's just given. And that is the reason. The next thing that we want to do is we're going to label this angle here as X. Angle X. Then we're going to say that angle 1 and angle X are linear pairs. Well, actually, we're going to say that they add to 180. And the reason for that, is because they are a linear pair. That's just the definition of linear pair. Right? Because they're on this line right here. Angle 1 and angle X are on that line, so they're a linear pair. They make this line. And then we're going to say that angle 2 and angle X add to 180. And this is called a paragraph proof because I'm writing it like a paragraph. We're going to do tomorrow, we'll do a 2-column proof. So those add to 180 because, so I'm going to draw this arrow, the reason being is different. If we go back to our postulates, we would find the same side interior postulate. And that postulate says that same side interior angles add to 180. I'm just going to abbreviate as postulate. Now that we have that information, we can, and these just take practice, so it's kind of like you memorize it until you can do it on your own. We can say that angle X is equal to 180 degrees minus angle 1, but angle X is also equal to 180 degrees minus angle 2. Well, from here, and that's just going off of what we said previously, right? Like if they add to 180, then we can do the subtraction of it to find out what that angle is. And that would just be the subtraction equality. All right, so that's the reason for that. But if we can say that, then we can say that 180 minus angle 1 is equal to 180 minus angle 2. But if you look, we can cancel this. We can cancel out the negatives as well so that we get to angle 1 is equal to angle 2. That canceling is the subtraction property of equality as well. So the reason why this is true is because of the subtraction property of equality. And I should have put that up there, the subtraction property of equality. So same reason. And that's what we wanted to figure out, was that these are congruent. Right? That's what we were trying to prove this whole time. And so once we get to that, we've solved our proof. Prove corresponding angles are congruent.